this column. Now I have to identify in which row is that particular key. Now in order to do that, now I have to go for energizing each of these row at once. That is what I do in the next step. Now what I'm doing now, start writing logic 1 to the rows sequentially. First I'll write, initially this was 0. Now I'm making this particular row as high. So this row is made as I. You can see the red line. This is I. Now I'm making this high will not help me. This will not turn the C2 to 1. C2 is still remaining 0 because I have not pressed anything in this row. Next, now I'll just observe C2. Yeah, C2 is still 0. That means what? I have not pressed anything in row 1. Next, I'll go for energizing row 2. Now, and this is again made as 0. Now, when I energize rows 2, this is pulled again to 1, pulled back to 1. That means what? I have pressed some key in row 2. I previously understood I have pressed some key in column 2, and now I understood. So I have pressed when this C2 changes from 0 to 1, I'll be examining for this. Now I understood I have pressed some key from row 2. Now initially I understood it was from column 2. Now I understood it as row 2. It is this particular key. It is this particular key. This is how we identify the key pressed. Now when it is column 2 and row 2, I'll go for assigning this value. What value? I'll show you here. This value, that is 5. Now all these things we do in software. Okay. Yeah, this is done. I hope you understood till here. Yeah, and the implementation, I was telling the software, it is just the keypad which is connected to the microprocessor, the controller. When I press some button, how it is going to take the value associated with that button. Now we are not going to store this value inside the button. It is just a switch. Now if I press this switch, the software will say it is the value 5. Now how? See, I have an infinite loop. This will be running in an infinite loop. So first what I do, if C1 is equal to low, that is what I'm checking. So column 1, this is column 1. So this is column 1. I have the picture here also. Now initially all these lines are made I. Now I'm checking. Now if I press something, I'm just checking whether I pressed something in column 1. If I not pressed anything in column 1, then I'll go for checking whether I pressed anything in column 2. And then if I not pressed, if C2 is also not low, then I'll go for checking whether I pressed anything in C3. Similarly, if I have not pressed anything in C3 also, then I'll go for checking whether I pressed anything in C4. So this I'll be repeatedly checking because I've written this inside the while loop. Now this while loop will be running forever and it will be checking on every iteration whether I've pressed anything in column 1, column 2, column 3 and column 4. Now let me assume I press something here. I press this button. Okay. Now which column is this? Column 1. Now C1 is equal to low. If I press something here, and rows are connected to logic zeros. If I press this button, so this column will go 0. This will go 0. This is 0, 1, 1, 1. Now C1 is equal to 0. Now low. That is what I'm checking. The condition is true. Next. Now if this is true, it is understood that I have pressed some switch in the column 1. Now I have to find out which row I have pressed it. Now I'll make intentionally R1 is equal to I. This is what I'm doing here. R1 is equal to I. I want to check R1 is equal to I. R1 is made as I, and when I make R1 I, I'll check again if C1 is equal to I. If C1 is I, C1 changes from low to I, so then I display 1. So this is 1, this is 1. Right now, so this is not the switch I've pressed this switch. This condition is false right now. Now C1 is made as C1 is equal to low. It's sure I've pressed something here in the column 1, but when I make R1 is equal to I, C1 is not changing to I because I've pressed this. C1 will not change to I. Now I'll come to the else part. Next I'll make R2 as I. So this is made as high. Now when I make this as I, so this C1 which was low will change to I. I'm checking here. If C1 is equal to I, then display what? 4. What is the key value? 4. Display 4. Print 4. So this is it. Now if I and similarly let me assume I am pressing this button. This is in column 2. When I press this, what will happen? C2 will become 0. Now C1 is equal to low, condition is false, where it will go? Here. C2 is equal to low. This is true. Now I have to check where I have pressed, in which row I have pressed. Initially I make row 1 as I. Now when I make row 1 as I, this will not change. C2 will not change from low to I. So condition is false. Now again I go to the else part, make R2 as I. R2 as I, no, because this is what I have pressed. This will still remain in 0. Next it will go to this else part, make R3 as I. Now this is made as I, this is made as I, and again this still remains, C2 remains in low. And now if when it's confirmed, this is also not what I have pressed. This is also the button which I have not pressed, and I have not pressed this also, and obviously it should be what? This. In the else part I have written update 0 or display 0. This is the key value. And similarly, if I assume I press something here, so C4 will go to 0. Now where it will come? To C4. C4 is low, then I'll start again sequentially, making this R1I, this high, and when I make this I, the C4 will change to I. Here C4 is equal to I, and then display what? Sorry. Yeah, here R3 is equal to, when I make R3 is equal to I, C4 will change to I and display what? C. So this is how it works. Hope you people understood. This is the simple program, which is used in order to explain you how the software of the keypad works, and this will be running continuously. That means the moment you press any button, immediately the column is detected. Once the column is detected, it will go for immediately detecting the row also. So this happens the moment, all these things will happen the moment you press and release the button. You just press and release the button, it will happen. Yeah, now I hope you understood the keypad. Okay, yeah. And the next thing is programmable peripheral interface, or the programmable interface device 8255. Now majority of the times the processor or the controller will have limited input output ports. Now if I want to extend the input output ports of the processor or the microcontroller, then I can go for using the programmable interface device. Now generally microcontrollers will have the sufficient number of input output ports, but the processor will not have the sufficient number of input output ports. That time you can extend the input output capability of the processors or in general the microcontrollers also by using the programmable peripheral interface device. So and there is one such programmable peripheral interface device, that is 8255. So this is the IC number. Now using this you can extend the input output capability of the processor or the controller. And this 8255 which is a programmable interface. Why this is called programmable interface device? Because you can program this. How you can program this, I'll tell you, because it has an associated control word register. Using that control word register you can program 8255 as you need. Now 8255 has 24, it's a 24 input output pin, and this 24 IO pins are grouped as port A, port B and port C. Each one is an 8-bit port. This is an 8-bit port, port B is again an 8-bit port, and port C is again an 8-bit port. Now 8 plus 8 plus 8, it is totally 24. Now this is how the IO pins of 8255 grouped. They are grouped as port A, port B and port C. Port A is an 8-bit port, and similarly port B is again an 8-bit port, and port C is also an 8-bit port. 8 into 3 is 24. So 24. And again one speciality, this port A is again an individual 8-bit port, and port B is an individual 8-bit port, but port C is divided like this. Port C can be operated in 4-bit fashion also, 4-bit port also. Port C is divided as port C upper and port C lower. So port C lower as P0 to P3, and similarly port C upper as P4 to P7, totally 8. So this is port C lower 4-bit port and port C upper 4-bit port. In case if you need, if you want to use only 4 bits of the port C, then you can use it. Now 8255, which is a programmable peripheral interface device, which can be used in order to extend the I/O capability of the microprocessor or the microcontroller. So operates in 2 modes. One is bit set reset mode, normally called as BSR mode. Another one is input output mode. Now what is bit set reset mode? In bit set reset mode, you can use the 8255 in order to just set and reset the bits of the port C. Now bit set reset mode is used to set or reset the bits of the port C only. So for example, BSR mode, always D7 will be 0. See, this is the control word register, which is used in order to program the 8255. It's an 8-bit register. Control word register is an 8-bit register. You can see D0 to D7. Now if I want to make 8255 operate in BSR mode, I want to make the D7 bit as 0. If I make D7 bit as 0, you have 8255 operating in bit set reset mode. And what is that you can do in this bit set reset mode? So this D6, D5 and D4 don't care. That means they can be either 0 or 1. And D3, D2, D1 are the bits inside the control register used to select the bit from the port C. So port C has 8 bits, which is divided into port C lower and port C upper. So in general it has 8 bits from PC0 to PC7. Now you have 3 bits reserved here, D3, D2, D1, in order to select each bit of port C. Since it has 8 bits, now there are 3 bits reserved, 0, 0, 0 to 1, 1, 1. So just to select each bit of port C. I want to say select 0th bit of port C, then what is the value I have to give here? 0, 0, 0. And similarly, if I want to select the first bit of port C, I have to give 0, 0, 1. Similarly, if I want to select the 7th bit of port C, I have to give 1, 1, 1. The value which I can vary using D3, D2, D1 is from 0, 0, 0 to 1, 1, 1. And similarly, so this D0 holds the bit value which I want to keep, whether I want to set or reset. If I want to set, I'll be giving it as 1. If I want to reset, I'll be giving it as 0. Say for example, I want to set the 0th bit of port C, so this I'll be making as 0, 0, 0, and this I'll be giving it as 1. If I want to reset the 0th bit of port C, this is 0, 0, 0, and I'll be giving it as 0. So this BSR mode is basically used in order to set or reset the bits of port C only. You cannot reset the bits of port A or port B. Now when you want to operate 8255 in BSR mode, so it is mandatory to make D7 bit as 0. Now if you want to operate 8255 in input output mode, then you have to make D7 bit as 1. Now input output mode, this mode is selected when the D7 bit of the control register is 1. So that is what. If you make this D7 bit as 1, so you have 8255 operating in input output mode. And again, this mode has 3 different modes. Input output mode, there are 3 different modes. One is mode 0, mode 1 and mode 2. It's called as mode 0, mode 1 and mode 3. Now mode 0 is a simple IO mode or basic input output mode. In this mode, all ports A, B, C can be used as input or output mode. Now when I make this bit as 1, so this 8255 is operating in input output mode. And again, now this mode 0 is a simple mode, simple input output mode. In this mode, all 3 register can operate. All 3 register all 3 ports, port A, port B and port C, can operate in the simple input output mode. And similarly, the other mode is mode 1, which is called as an handshake mode. Now here only port A, port B can be made to operate in the handshake mode. And there is another mode, bidirectional IO mode, input output mode. In this mode only port A can work, so B and C cannot work in the bidirectional mode. Now Now here in simple IO mode, all three ports can be made to operate in simple input output mode. That means you can make port A as input or output, port B as input or output, and port C again as input or output. But in handshake control mode, only port A and port B can operate in the input output mode, handshake input output mode, and port C is used for handshaking. What is this handshaking? That means before any data is transferred in and out of the port, handshaking, that is exchanging the signal, and then agreeing for data exchange, and then go for exchanging the actual data. So bidirectional, that means the communication is simultaneously possible in both the direction, from the device to the ports of the processor or microcontroller, or from the ports of the microcontroller to the device, and only port A is used for that purpose. So these are the three different modes in the input output mode. And now you understood mode 0, all three ports can operate, and mode 1 only A and B can operate, and mode 3 only A can operate. Or in other words, so port C can operate in only one mode. What is that mode? Simple IO mode. Port C cannot operate in handshake mode, and port C cannot operate in bidirectional mode. And port B can operate in two modes, that is simple IO mode and handshake mode, and port B cannot operate in bidirectional mode. Port A, if I take, it can operate on all the three modes. Now, this is the again control word register format. I told before coming to this, let me go to the next thing. This one I'll explain. Now 8255 simplified control word register. It is an 8-bit register. Now if I want to operate the 8255 in the input output mode, D7 is always made as 1. If I want to operate 8255 in the bit set reset mode, I have to make this as 0. Now we'll see, now we are in the earlier, so we made it to operate in the bit set reset mode by making D7 as 0. Now here we are making it to operate in the input output mode by making it as 1. We'll see what the other bits are. D0, it is the IO function for PC lower. I told the port C is divided into port C lower and port C upper. So this D0 bit is reserved for making port C lower either as input or as output. So this is the bit which is reserved for doing that. Now if I want to make port C lower as act as output, then I have to make this particular bit as 0. And if I want to make port C lower act as the input, then this bit I have to make it as 1. That means this bit is reserved for port C lower in order to make it either as input or output. How do you make port C lower as input? By making it as 1. How do you make port C lower as output? By making this particular bit as 0. And similarly, the next bit D1 is the IO function for port B. This says whether you're using port B as input port or as output port. Now how do I make port B as input port? By making it as output port by making it as 0. How do I make port B as input port? By making this bit as 1. And similarly, the next bit D2 is reserved for mode of port B. Now I told port B can operate in two modes, that is mode 0 and mode 1, that is simple IO mode and strobed IO mode or handshake IO mode. Since it operates in two modes, I have one bit reserved for it. One bit is sufficient because using one bit you can specify both the modes. If I make this bit as 0, you have port B operating in simple IO mode. If I make this bit as 1, so you have port B operating in strobed IO mode. And similarly, D3 is the bit which is reserved for the input output function of PCU, port C upper, for that is from PC4 to PT7. If I want to make port C upper also act as the output port, then this I'll be making it as 0. If I want the port C upper to act as the input port, this I'll be making it as 1. And next bit is for the IO function of port A. So if port A I want to use it as output, I have to make this particular bit as 0. If I want to use port A as input, I have to make this particular bit as 1. And similarly, now D6 and D5 are reserved to specify the mode of port A. I told port A operates in three modes, that is mode 0, mode 1 and mode 2, that is simple IO mode, strobed IO mode and the bidirectional IO mode. Since it operates in 3 modes, 1 bit is not sufficient, you require 2 bits. Now if D6 and D5 is 0 0, if D6 is 0 and D5 is 0, it operates in simple IO mode. And similarly, how to make port A operate in the strobed IO mode? This you have to make 0 and this you have to make 1. It operates in strobed IO mode or mode 1. And if you make this one, this is either 0 or 1, it operates in the bidirectional mode. Hence 2 bits are reserved for it. If you reserve only 1 bit, it is not possible for you to specify all the 3 modes of the port A. And there is no bit reserved for port C mode, because you know port C operates always in only one mode, that is simple IO mode. So this is the control word register format, and you have to remember this. And D7 for input, when you are operating 8255 in the input mode, is always 1. If you want to operate 8255 in the BSR mode, this is 0. And these 3 are don't care, and these 3 bits will specify which bit of port C you want to set or reset, and the set or reset value goes to D0. I hope you understood the format of the control word register. Now here also the same thing is given. This C 0, what it will do, port C lower, that is PC0 to PC3. Now to make them port C lower as input, you have to make it as 1. To make it as output, you have to make it as 0. You can easily remember input, I will come right. So 1 always input and 0 is output. You can easily remember. So 0 is output. So you will not get a confusion. And next, this bit is again port B, whether to make it as input or output. If you want to make port B as input, 1, port B as output, 0. And similarly, this is mode of port B. You know port B operates in 2 modes, hence only 1 bit is reserved. 0, it operates in simple IO mode. If port B operates in simple IO mode. If you make this as 1, port B operates in strobed IO mode. And this is for mode of port C upper IO function. If I want to make port C upper, that is PC4 to PC7, operate as input mode, so this bit I'll be making it as 1, otherwise I'll be making it as 0. It operates as output. And this is IO function of port A. If this I make it as 1, it will operate in input mode. If I make this as 0, port A will operate in as output port. And these 2 bits are reserved for mode of port A, because it operates in all the 3 modes. This, and this is again to make the 8255 operate in the BSR mode. Make this as 0, and these 3 is don't care, they can be anything, and these 3 for selecting the bit from the port C, and this is for setting or resetting. This is understood. I have examples also. Just go through this. Write a control word for simple IO mode for making port A, port B as input. You have to make now port A as, so that is the reason it is called as programmed peripheral interface device. 8255 is a programmable interface device, because using this control word register you can make port A, port B, port C either as input port or as output port as you desire. Now I have the example here. Now I want to make 8255 operate in a simple IO mode and make port A, port B as input port and port C upper and port C lower as output port. Now this is I have written here. Since it says operate it in a simple IO mode, correct, right? And this must be what? 1. It is acting as input output port. This is always 1. I have made it as 1. Next, what it says is simple IO mode. I want to make port A operate in simple IO mode and port B also operate in simple IO mode, and port C, correct, no? Port A should be port C always operate in simple IO mode. There is no bit reserved for it, but port A, port B operates in 2 modes and port A operates in 3 modes. Now what mode I have to operate port A? I have to operate it in simple IO mode. Simple IO. For operating it in simple IO mode or mode 0, now these 2 bits, correct, no? What they should be? 0 0. I have made them as 0 0, and then port B also have to make it operate in simple IO mode. So this is the bit reserved for port B to operate it in simple IO mode. So the D2 bit, so the 3rd bit from the right. So this is also made as 0, and Next, yeah, or let me come from this side. Now, so this bit is what? D0. So there is port C lower, IO function of port C lower. Now port C lower, what is that you have to do? You have to make it as output port. Hence this is made as 0. Because 0 is nothing but what? Output. Next, this D1 is what? IO function of port B. Now what is port B? Port B, I have to make it as input port. See, that is the reason it is made as 1. Now, yeah, sorry, here it is written wrong. 1 means input and 0 means output. So don't confuse. This is wrong. Here it is correct. See here. This is the bit right. 1 means input, 0 means output. Yeah, here it is wrong. Sorry. I'll change this in my PPT. 1 means input and 0 means output. So these two has to be interchanged. Always remember 1 means input and 0 means output. Here it is interchanged. But this one is correct. I'll try to change this in my PPT. Now for now you make a correction. Now 1 is input and 0 is output. Yeah, here it is correct. 1 is input, 0 is output, but here and here this is also correct. 1 is input, 0 is output. So only here I have gone wrong, only here, and here also it is correct. Only this is wrong. Sorry for the mistake here. So I'll correct this in the PPT. Okay. Now I'll come here. Now what is that I have to do? Port B, I have to make it as input. Since it is input, I have to make this bit as 1. Next, D2 is what? Mode of port B. In which mode I have to operate the simple IO mode. To make port B to operate in simple IO mode, I have to give it as 0. See here. Now mode 0, to make port B to operate